Hello students, welcome to Lucky Learning. Here in this video, I am going to discuss the concept of addressing modes in the computer organization and architecture subject. The operation field of the instruction specifies what operation to be performed. This operation must be executed on some data that is stored in the computer registers or in the memory words. Now we have to find the way the operands are chosen during the program execution is depending on the addressing mode of the instruction. It means what is an addressing mode? Addressing mode specifies a rule for interpreting or modifying the address field of the instruction before the operand is actually referenced. Now, how the operand is to be referenced for performing particular operation, that is going to be decided by the addressing mode of the instruction. That addressing mode specifies a rule for interpreting or modifying the address field of the instruction. In the address field of the instruction, we specify something that is to be interpreted or to be modified further so that we can find the address of the operand on which it requires to perform the operation. What is the purpose of addressing mode? To give the program versatility to the user. Let us an example, if we have a pointers to memory and counters for loop, indexing of data uses addressing modes so that addressing becomes easy and instruction lengths can be varied. Now, to reduce the number of bits in the addressing field of the instructions, we use addressing modes. To understand the various addressing modes, we must understand the instruction cycle. The instruction cycle is to fetch the instruction from memory and PC gets incremented. Then it has to decode the instructions, calculate the effective address, execute the instruction. Now, what the program counter contains, the PC keeps track of the instruction in the program stored in the memory. Now, PC holds the address of the instruction that is to be executed next. And the PC is incremented each time an instruction is fetched from the memory. The addressing mode of the instruction consisting of distinct binary code. This instruction format will be a mode field, operation code, address field. And single binary code format uses operation code plus mode field together and along with address is there in the instruction. And there are different addressing modes. There are totally of 10 addressing modes that we are going to study to interpret the address part of the instructions. Those are called implied mode, immediate mode, register indirect mode, auto increment or auto decrement mode, direct address mode, indirect address mode, relative address mode, indexed addressing mode, base register addressing modes. We'll discuss each one of them in detail with respect to an example. Implied mode. In implied mode, operands are specified implicitly in the definition of the instruction. So means operand by default already there in the instruction. Say accumulator is by default in the add of memory at location AR. What it happens, this add instruction is going to add the operand in the memory at that location with the accumulator value. So means the memory at address location AR is added with accumulator. One of the operand is already there. That is called implied mode. Means one of the operand is by default. And when it comes to the stack organization, the add instruction is going to add the top two operands. The top two operands are by default in the add instructions for the zero address instructions. Implied mode says that operand is by default within the instructions, as in the case of first one, accumulator is by default. In the second one, The top two operands are by default. Second, immediate mode. The operand is specified in the instruction itself. So operand is specified in the instruction itself means it is not the address of memory or it is not the register. It is directly the value in the instruction. Operand field contains the actual operand, not the address. Usually, we use immediate mode for initializing the registers. Let us an example, move R1, comma 5. It means the operand is 5, that is directly value that is copied into R1 registers. When the instruction has actual operand, we call it is immediate mode. Third one, register mode. In the register modes, operands are in the CPU registers. And register is selected from a register field in the instruction, and we use k-bit address for addressing 2 power k registers. Let us say load R1. It means the R1 value is loaded into accumulator. Now I can say this example is also an example of implied mode. Why? Because one of the operand is by default and it uses register so that this register value is stored into the accumulator. Then we can call it is also register mode. Register indirect mode. The instruction specifies a register in the CPU and the contents of that CPU register gives again the address of the operand in the memory. Let us an example load R1. Now what R1 contains? R1 contains some address. And when you go to that address in the location of the memory, you can have the operand. That operand will be loaded into the accumulator. Means the micro instruction will be like this. Accumulator is loaded with the memory at location that contains the value of R1. So means the value of R1 is an address, memory at value of R1. R1 contains address, memory at that address location, we have some value. That value is loaded into accumulator. Now, what is the advantage of this register indirect addressing mode? We use only fewer number of bits to select a register. Suppose we have 16 registers and it means to select one of the register we use only 4 bits because 16 is equals to the power of 4. In the address part of the instruction, we should specify only 4 bits, not the 12 bits if it is in the case of memory contains 2 to the power of 12 words. Means 2 power 12 means 4096 words are there in the memory. So representing each word we use 12 bits. But if that address is stored into the register, the address part now contains only 4 bits. So the number of bits are going to be reduced if you use register indirect mode. Fifth one, auto increment or auto decrement mode. This is same as register indirect, but when address in the register is used to access the memory, the value in the register is incremented or decremented by 1. Let us say load R1. We use this kind of notation for register indirect mode plus. So what happens? The value of address location, that address is there in the register 1 means M of R1 is loaded into accumulator, right? So when the address is in the register is used to access the memory, the value in the register is incremented or decremented by 1 after or before the execution. Means assuming this is after the execution of loading the operand that is there in the memory whose address is there in the R1 register is loaded into accumulator. After that, the R1 value gets incremented. Let us say R1 has address 100. That memory at 100th location value is loaded into accumulator. After that, R1 is going to be incremented by 101. This is called auto increment or auto decrement mode. Is the fifth one. Sixth one, direct mode. Direct mode means the operand residing in the memory and its address is given directly by the address field. Let us say load the accumulator with the value that is there in the 100th location. Means memory at 100th location had some value that is loaded into accumulator. Means the address part of the instruction is directly the address of the operand. We call direct addressing mode. When it comes to the indirect addressing mode, the address field of the instruction gives again address where the operand is stored. We call this is effective address. It means if I have an instruction load 100, it means it has to go to the 100th location in the memory. In the 100th location in the memory, again you have an address, and again you can go to that location, and that location now will have an operand. That operand is to be loaded into the accumulator. This is called indirect address mode. Eighth one, relative addressing mode. In relative addressing mode, what is to be done? PC is to be added with relative address. Actually, the content of the PC program counter is added to the address part of the instruction in order to obtain the effective address. So it means, suppose if it is load with some relative position uh, at 10, assuming this is a 10th instruction, or assuming this is a 20th instruction. Now PC contains 21 instructions. Now what is to be loaded? Now it is to be loaded some value that is there 10 instructions far from the current instruction. Now the current instruction is 20 and the PC contains 21. So what it happens, the 21 plus 10, the memory at address 21 plus 10 means it has to go to the 31 location. In the 31 location, we have some value. That value is going to copy it into the memory. That value is going to copy it into the accumulator, right? It means the PC is added with the relative address. Means relatively how many positions far the operand is available. That is called relative address mode. Ninth is index addressing mode. In this mode, the content of an index register is added to the address part of the instruction. The content of an index register is added to the address part of the instruction. Like it is just like addressing the array elements. Suppose the index register XR, assuming it is having 100. Suppose add or else load $1. What does it mean it will do? It has to load the accumulator with the memory at location 100 plus 1. Assuming it is array elements are there at the 100th location. In the 100th location, we have a element 5. Next, it has to load the memory location 101 value into accumulator. Then in such cases, instead of giving the address 101, we can say 1. It so that what it happens, it is going to add this index register value with that 1. This is index addressing mode. Especially it will be used for accessing the sequence of consecutive elements. And the same thing, we can also use another type of registers called base register addressing mode, where the contents of the base register is added to the address part of the instruction to obtain the effective address. So the base register, assuming when I'm talking about arrays, the starting address is stored into the base register and the relative positions of the elements are represented with some address value like 0, 0, 1, 2, 3, and so on. So that consecutively we can access all the elements by iterating through a loop. And we will understand these things with respect to a numerical example. Now, what we have discussed? What we have discussed? First one, implied mode. Assuming this is a to address instruction, load to accumulator, and that mode value, and the address field is 500. What is the first one? implied addressing mode. In the implied addressing mode, the address part contains 500. That 500th location, we have value 800. That value 800 is loaded into the accumulator. Accumulator is loaded with 800 in the case of implied mode, because it is a load, simple, not accumulator, assuming it is load. So by default, operand is accumulate. Okay. Next is immediate mode. In the immediate mode, this address part contains the value. Address part contains the value means this 500 is not an address, so that what it can store, that 500 value stored into the accumulator. And when it comes to the direct addressing mode, so it has to go to the 500th location. In the 500th location, value 800 is there. 800 is going to be stored into the accumulator. When in the case of indirect addressing mode, so it has to go to 500th location. In the 500th location, we have 800. Again, it is considered as an address, and go to this 800 address. What value is there? 300. That 300 is stored into the accumulator. When in the case of register addressing mode, suppose addressing mode, address part is contains some register R1. What is there in the R1? 400. Now, the 400th location, what value is there? 700. That 700 is copied into accumulator in the case of register addressing mode. When in the case of register indirect addressing mode, so address part of the instruction contains register. Register 1 value is 400. When you go to the 400th location, we have again 700. That 700 is an address. Now, when you go to the 700th location, assuming we have some value 600, that 600 is going to be stored into the accumulator in the case of register indirect addressing mode. Suppose when I'm talking about auto increment or auto decrement. So after loading this register value, means like go to 400th location. In the 400th location, we have 700, and it stores the 700 into the accumulator. After storing 700 into accumulator, register value can be incremented by 1. In the case of auto increment, it is decremented by 1 in the case of auto decrement. And we also have relative addressing mode and base register addressing mode. What is there in the address part? 500. If it is a relative addressing mode, what happens? This PC is added with 500, so that it is 700. It will go to that 700th location. In that 700th location, what value is there? 600. That is going to be loaded. When in the case of base register indirect addressing mode, in base register addressing mode, the address part contains 500. That is going to be added with index register. Sorry, it is indexed addressing mode. This is to be added with 500. Now 100 plus 500, 600. Go to 600th location. So what is there in the 600 location? 900. Similarly, base register indirect addressing mode, assuming I do have base register of 400. Now, what address part contains 500? This 400 is added with 500. Now it is 900. It will go to that 900th location in the memory. In the 900th location, we have a 666 that is going to be copied into the accumulator. Now, this is one numerical example to explain you all the 10 addressing modes. Hope you have understood these addressing modes clearly. If you like the video, please share with your friends. Do like and subscribe and click the bell icon for the regular updates. Thank you.